Welcome to On Chemistry. In this video, we are going to see Michael addition reaction. It is a regioselective reaction, technically 1,4 addition reaction. We will see shortcuts and mechanism behind the reactivity. Stay tuned. Here are given quick facts for your reference. Basically, the reaction all about nucleophile. If it is hot, 1,2 addition. If it is soft, 1,4 addition. So you should know what is soft nucleophile, what is hard nucleophiles. Simple rule of thumb is copper and carbon based nucleophiles are soft nucleophiles, undergo 1,4 addition. Hard nucleophiles are mostly magnesium lithium based. It will undergo 1,2 addition. So soft nucleophiles are low charge and big size. Hard nucleophiles are high charge and small size. The simple shortcut is soft. F stands for 4. So don't get confused. Hard mean 1,2 addition. Soft mean 1,4 addition. First, let us see Michael addition reaction. Basically, the reaction happen in conjugated ketone, alpha, beta, unsaturated ketone. Here is on cyclic ketone. In alpha position, you have alkene. If you look at the architecture, totally 4 carbon involved in that. The number starts with oxygen 1, 2, 3, 4. It is basically a addition reaction. If it is a hard nucleophile, addition happen at 1, 2 position. If it is a soft nucleophile, addition happen at the 1, 4 position. So you should know how alkene behaves with nucleophile. Basically a selectivity in addition reaction. Then we will see separately each addition reaction. First, let us see 1,2 addition reaction. If you use hard nucleophile, say Grignard reagent, methyl magnesium bromide, addition happen at 1,2 position. So nucleophile attacks the carbonyl at second position. So CH3 attacks, you have O minus. For convenience, I shown as multiple steps, but you can go with mechanism. Once CH3 attacks, O possesses negative charge. It quenched by H plus. So you end up with alcohol. So if you clearly look at it, nucleophilic addition reaction happened. First position hydrogen added. Second position methyl group added. That's why it is called 1,2 addition reaction. Here there is no selectivity. You have simple addition reaction. Now we are getting into the important one, that is 1,4 addition reaction. It is new and novel. That's why it is called Michael addition reaction. Here the same architecture, but if you use soft nucleophile, say copper nucleophile, organometallic compound, the methyl group attacks fourth position instead of second position. So electron cascade happened. Fourth position addition leads to O minus with shift in double bond. So O minus is there, it quenched by H plus. You have alcohol, it is the enol. If you convert into ketone, if you look at it, it is technically 1,4 addition. First carbon has hydrogen, fourth carbon has methyl group. So with soft nucleophile, Michael addition happened with 1,4 position. Basically, it is a regioselective reaction. Methyl added to fourth position instead of second position. Here you may wonder why 1,4 addition. Technically hard-soft interaction. The carbon-carbonyl is the hard nucleophile. Charge is localized, so considered as hard and small. So hard nucleophile attack hard carbon. So attack happen preferably in the second position if it is hard. According to hard-soft theory, if it is hard, attack happen at second position. On the contrary, if it is soft, attack happen on the fourth position. There are many other definitions and different theories are also available. I given a simple possible one. If you are interested, go and study separately. Here we are seeing the important detail, the nucleophiles. You should know which nucleophiles are soft, which nucleophiles are hard. Soft nucleophiles undergo 1,4 addition. Basically, they have low charge and big size. Copper nucleophiles are soft. carbon nucleophiles are soft, basically enolate. Then cyanides, thiols, amines, alcohol and bromine, technically halides, then enamine and sulfoxyylide. See, thiol is soft, sulfoxide is ylide, and sulfur ylides are hard. So hard nucleophiles mostly with hard metals, magnesium, lithium, sulfur ylides, alkene and aromatic system. So simple thumb of rule is hard nucleophiles are high charge and small size. So you should master nature of nucleophile. You should identify which is hard, which is soft. Here little bit advanced concept. The library of Michael Donor and Michael Acceptor. Michael Donor is mostly nucleophile. Michael Acceptor is carnel. Not only happen with the simple ketone, it can be happen with allied system, say ester, ketone, aldehyde, and cyanide. Michael donors are mostly active methylene group with 2 electron withdrawing groups. It can be cyanide, it can be ester, and cyanide or simple nitro group. Michael acceptors are basically a conjugated system. It can be with cyanide, aldehyde, ketone, ester. So basically you should master what are all reaction center, what is Michael donor, Michael acceptor. Problems are best way to learn. So I discuss some problems. Problems give you understanding and good clarity. We will learn by the comparison. So first problem will be cyclic conjugated ketone, cyclohexenone. One reaction is sodium borohydride with methanol. Another reaction is with sodium borohydride with cerium chloride. You should find how the reagent behave and give different product. Here reagent induce the selectivity, not the reactant. Here nucleophile is same, which is H minus. Only different is reagent induce the selectivity. Here cerium if you are using, which is create the hard condition. So 1,2 addition happen, it behave like magnesium. H minus attacks, you have simple 1,2 addition reaction, simple reduction. On the contrary, if you use simple sodium borohydride, hydrate behave like soft nucleophile, attack happen on fourth position, charge travels, you have O minus, then H plus quench the O minus, you have enol, then enol undergo tautomerism, you have final product. One case you have cyclohexenol, another case you have simple ketone. Here the concept you have learned here is reagents can also promote selectivity in addition reaction. Then the next example, the starting material is cyclohexene system with ketone and side chain alkene. It is like terminoids architecture. The reagents are sulfur ylide and sulfoxyylide. Ylides are positive and negative charge compound like ionic compounds. You should find how two different reagents behave and give different product. Here you should know the fact that sulfur ylide is hard ylide, sulfoxyylide is soft ylide. So sulfur ylide undergo 1,2 addition, sulfoxyylide undergo 1,4 addition. So sulfoxyylide 1,4 addition means the conjugated alkene get reduced. It is a important selectivity. Ylide attacks the fourth carbon, charge travels. Then you have bridge methylene group. On the contrary, if you attack with sulfur ylide, it is a hard nucleophile. Attack happen on second position. You have 1,2 addition. O minus attacks the CH2. You have bridge methylene group. So epoxide happen at carbonyl. Another case it happens cyclopropane. So two different reagent, two different product. Then the next example, starting material is cyclohexenone. One reagent is methyl magnesium bromide. Another reagent is dimethyl copper lithium. You should find what will be the final product in each cases. By now you may understand that the knowledge on hard and soft is important. Magnesium nucleophiles are hard. copper nucleophiles are soft. So copper undergo 1,4 addition. Methyl group add into fourth position. Charge travels, you have O minus. Then H plus attacks, you have OH. Then hetoenol tautomerism occur, you have final product. On the contrary, methyl provide hard nucleophile. The attack happen on second position. You have 1,4 addition. So the concept you have to learn here is magnesium nucleophiles are hard, copper based nucleophiles are soft. Then the next example, starting material is a linear compound which is alpha beta unsaturated compound. Starting materials are alkyl lithium and thiol. You should find what will be the final product. Here basically your knowledge on nucleophile is important. Lithium is a small metal with charges, so it is hard. It provides hard nucleophile. Sulfur is big, polarizable and behave like soft. So lithium undergo 1,2 addition. Sulfur undergo 1,4 addition. So in lithium case, addition happen at second position. Alkyl attacks second position. H plus added. You have final alcohol. On the contrary, sulfur undergo 1,4 addition. The attack happened on the fourth position. Double bond shifted. You have enol. Then enol undergo tautomerism. You have ketone there. The concept you have to learn here is sulfur nucleophiles are soft. It will undergo 1,4 addition. Then the next example. Here you have cyclohexane. Side chain you have alkene, that is conjugated ketone, alpha, beta and saturated position. You are using hydrogen cyanide and potassium cyanide. You should find what will be the final product. So starting material is conjugated ketone. So chances of nucleophilic addition reaction. But you should know nature of nucleophile. Here cyanide is the soft nucleophile. It will undergo 1,4 addition. So cyanide attacks the fourth position. Double bond switches. You have O minus. Then quenched by H plus. You have enol. Then hetoenol tautomerism occur. Enol convert into ketone. So final product is 1,4 addition product ketone. The concept you have to learn here is cyanide nucleophiles are soft. It will undergo 1,4 addition.